Up until now, we've been talking about spontaneous reaction. What if we want to do a reaction which is not spontaneous? This is called electrolysis. This is a reaction where we actually put a battery or some other outside source of power to make something happen. One of the examples they give in your book is molten NaCl that they separate into solid sodium and chlorine gas. Notice not the ions, solid sodium and chlorine gas. And one of the points they make in your book on page 883, 884 is a lot of times they'll do ionic things with molten ionic solids, meaning they actually melt the ionic solid. And one of the reasons that they do that is because if you have an aqueous solution, sometimes the water will get in the way. The water will be either reduced or oxidized instead of whatever it is you want to be reduced or oxidized. And I thought I would take this opportunity to show you the two reactions that water can possibly undergo. This is the oxidation of water. Water going to oxygen gas plus hydrogen ions plus 4 electrons. You'll notice that is under acidic conditions. And this one is the reduction of water. Water plus 2 electrons going to hydrogen gas plus 2 OH minus. So whatever happens to water does depend on pH. Now, this section of the chapter is very math-based. We can think about the math going on here. This is a shortcut diagram of the math that goes on in this chapter. Current, which is amperes, amps, and time is going to lead to the quantity of charge, which is coulombs, which is going to lead to the moles of electrons, which is Faradays, which is going to lead to the moles of substance being oxidized or reduced, which is going to lead to the grams of substance being oxidized or reduced. So if I've got a current, I can figure out grams. Or, conversely, I want to get that many grams, here's what current I need. That's the kind of math that's in this chapter. Let's do an example. This is, by the way, sample problem number 20.14 on the bottom of page 885 and the top of page 886. Calculate the number of grams of aluminum produced in 1 hour by the electrolysis of molten aluminum chloride if the electrical current is 10 amps. So we've got an amps, we've got a time, and we're looking for grams. So coulombs we know is amps times seconds. So we can say 10 amps times 1 hour, and then converting the hours into seconds, that's 3.6 times 10 to the 4th coulombs. Now we can do, oh look, dimensional analysis. 3.60 times 10 to the 4th coulombs, 96,485 coulombs for every mole of electrons. For aluminum, we have 3 moles of electrons, right, Al3+. 3 moles of electrons for every 1 mole of aluminum, and every 1 mole of aluminum is 27 grams, which gives us 3.36 grams of aluminum. That's all it is. It's dimensional analysis. Now, we've talked a little bit before about work. This is electrical work being done by the battery or whatever power source you've got. There's an equation for this. Work is equal to N times F times the E of the external power source, which actually leads us to a very real-world example, which is your electric bill. 1 watt is 1 joule per second, and 1 kilowatt hour is 3.6 times 10 to the 6 joules. A kilowatt hour is what your electric bill is billed in. If you have not seen your electric bill, go and ask your parents to show you your electric bill. The energy that you use is billed in kilowatt hours. And if you wanted to actually figure out what that was, there's your conversion. 3.6 times 10 to the 6th joules.